Hegel's Philosophy of Nature, paragraph 255. Space is implicitly the notion in general, and as such has the differences of the notion within itself. In its indifference, it has them immediately, as the three dimensions, which are merely different and quite devoid of determination. Remark: insofar as it is not a philosophical science, geometry may assume the universal determinations of space as its object, and it is not to be demanded of it that it should deduce the necessity of the three dimensions of space. The deduction of this necessity is founded upon the nature of the notion, but because of the non-philosophical nature of geometry, it is never considered. In this primary form of extrinsicality and abstract quantity, the determinations of the notion constitute a merely superficial and completely empty difference. Consequently, one cannot say how height, length and breadth differ from one another, because they are merely supposed to be distinctions. There is as yet no difference between them, and no determination is added by calling a direction height, length, or breadth. Height is more precisely determined as a direction from the middle of the earth, but a more concrete determination of this kind is irrelevant to the nature of space itself. Admitting this determination, it is still a matter of indifference whether we call a certain direction height or depth. It is the same with length or breadth, which is also often called depth, for nothing is determined in this way. Paragraph 256. B. Spatial difference is, however, essentially determinate and qualitative. As such, it is 1. In the first instance, the point, that is, the negation of the immediate and undifferentiated self-externality of space itself. 2. The negation is, however, the negation of space, and is therefore itself spatial. In that this relation is essential to the point is self-sublating and constitutes the line, which is the primary otherness or spatial being of the point. 3. The truth of otherness is, however, the negation of negation, and the line therefore passes over into the plane. Although one aspect of the plane is that it constitutes surface in general, in that it is a determinateness opposed to line and point, it also has the aspect of being the transcended negation of space, or the reinstatement of that spatial totality, which now has the negative moment within it. It is therefore an enclosing surface, which divides off and separates a distinct part of space. Remark: it is because of their notion that the line does not consist of points, nor the plane of lines, the line being rather the self-externality of the point, in that it relates itself to space and is self-sublating, and the plane likewise, being the transcended self-externality of the line. The point is here presented as that which is primary and positive, and it is from this that a beginning is made. The contrary is also true, however, for space may be considered as that which is positive, the plane as the first negation of space, and the line as the second negation, which, because it is the second, is in truth the self-relating negation of the point. The necessity of this transition is the same as it was in the first case. The necessity of this transition is not realized when the point and the line, etc., are grasped and defined in an external manner. The former kind of transition is, however, grasped as something contingent, when a manner of definition is used in which the line is said to arise from the movement of the point, etc. The other figurations of space treated in geometry are further qualitative limitations of an abstract division of space, of the plane, or of a bounded spatial unit. Moments of necessity also occur here, in the triangle, for example, which is the primary rectilinear figure, to which with the square all other figures must be reduced if they are to be determined, etc. The principle of these constructions is the identity of the understanding, which determines the figurations into regularity, and so establishes the relationship by which they may be understood. It may be noticed in passing that Kant was of the extraordinary opinion that the definition of a straight line, as the shortest distance between 2 points, is a synthetic proposition, because our conception of straightness is merely qualitative and does not involve size. In this sense, every definition is a synthetic proposition. That which is defined, which in this case is a straight line, is primarily nothing but an intuition or representation. As we have already seen in paragraph 229, in definitions such as this, it is the determination as the shortest distance between the 2 points, which first constitutes the notion. A definition is necessary here because the notion differs from the intuition not by being merely already present within it. Kant's definition is clearly analytic, since the straight line reduces itself to simplicity of direction, which, when taken in relation to quantity, yields the determination of the smallest quantity, and consequently of the shortest distance. Addition. It is only the straight line which is the primary determination of spatiality, for curved lines implicitly involve 2 dimensions. In the circle, we have the second power of the line. As the second negation, the plane has 2 dimensions, for the second negation is no less double than 2. If certain determinations are given, it is the task of the science of geometry to discover what other determinations follow from them. The main thing being that that which is given and that which follows should constitute a single developed totality. The central propositions of geometry are those in which a whole is postulated and expressed in its determinate elements. There are 2 such cardinal propositions involved in the complete determinability of the triangle. A. If one has any 3 elements of a triangle, one of which has to be a side, and there are 3 cases of this, the triangle is completely determined. Geometry deviates here into the easier but superfluous presentation of 2 triangles, which under these circumstances are supposed to be congruent. In fact, the proposition needs only 1 triangle, for the triangle in itself is such a relationship. If the first 3 parts of it are determined, so are the other 3, for the triangle is determined by 2 sides and an angle, or 2 angles and a side, etc. The first 3 elements constitute the determinability or notion of the triangle. The other 3 belong to its external reality and are superfluous to the notion. In such postulation, determination is still completely abstract, and there is only a general dependence, but the relation of specific determinateness in the size of the elements of the triangle is still lacking. This is B, reached in Pythagoras' theorem, which presents the perfect determinateness of the triangle, in that in it only the right angle is completely determined, its adjacent angle being equal to it. This theorem is therefore superior to all others as an illustration of the idea. It presents a whole which has divided itself within itself, just as each shape in philosophy is divided within itself as notion and reality. Here we have the same magnitude twice, first as the square of the hypotenuse, and then divided into the squares on the 2 cathetuses. There is a higher definition of the circle than that based on the equality of radii, in which difference is taken into account, so that the perfect determinateness of the circle is obtained. This occurs in the analytical treatment and contains nothing that is not found in Pythagoras' theorem. The cathetooses are the sine and the cosine, or abscissa and ordinate, and the hypotenuse is the radius. The relationship of these three constitutes the determinants of the circle. This is not, however, a simple relationship like that of the first definition, but a relationship of different elements. Euclid also concludes his first book with Pythagoras' theorem. After this, he is interested in bringing differences back to likeness, and he therefore concludes his second book by reducing the rectangle to the square. A hypotenuse contains the possibility of an infinite number of right-angled triangles, and a square likewise a number of rectangles. The circle is the place for both. It is in this way that geometry, as an abstract science of the understanding, proceeds scientifically.